Hey guys, in this video the brilliant Mr. B is going to be showing you how to collect like terms in algebra. Now this skill comes up over and over again and is one of the core things that you're going to need throughout your whole maths course. So it is definitely worth making sure you can do this really confidently. There are 15 different examples here, work through at 3 different levels, and you can work through this video as quickly or as slowly as you want to. It is completely up to you. Now if you want more questions to properly check you can do this, then there are loads more examples waiting for you over on my website.
We're going to have a look at simplifying algebraic expressions, or collecting like terms as it's known. So let's have a look at question 1. We've got 4a plus 6a, and this might not mean a lot to you, but a good way to think about adding and subtracting like terms is to treat the letter as an object. So for example, we could say 4a is 4 apples, and 6a is 6 apples. So if you've got 4 apples and 6 apples, altogether you would have 10 apples. And for adding and subtracting, it's really as easy as that. So moving on to question 2, let's try the same thing. So we can see that we've got 2 apples. We've got another 4 apples, so that would give us 6 apples altogether. And then another 3 apples, so the 6 apples plus 3 more apples would give us 9 apples. Now, moving on to question 3 is where it gets a little bit different. So we can see that we've got 2 apples again, but then we've got 8b. So we want to assign an object to b as well. So let's use bananas, why not? So 8 bananas, and then we've got 13 apples. So when we're adding all of this together, we can't add together apples and bananas. We could say we've got 10 fruit, but if we wrote down that we had 10f, 10 fruit, then we've lost some information. We've lost the fact that we had exactly 2 apples and exactly 8 bananas. When we're collecting like terms, you can only add together things that are the same, things that are alike. So we can't add together apples and bananas. We do have 2 sets of apples. We've got the 2 apples and the 13 apples. So altogether, that would be 15 apples. So what do we do about the bananas? Well, we just stick that on the end. So when we add all this up, we're saying that we've got 15 apples, we've got 8 bananas. Now again, we could add them together. We could say that we've got 23 fruit, but we've lost information. We don't know exactly how many apples and bananas we had. So we're going to leave it like that for our final answer. You'll also notice that I color-coded my answers. Now this is a really good technique for you to use. So you could use a highlighter and you could highlight the different symbols in different colors to help you picture how they add together. Or alternatively, you could do things like drawing circles around your apples and drawing squares around your bananas if you don't have highlighters. Let's take a look at question 4. And what I'm going to do, look at the apples first. So looking through the expression, I can see that we've got 10 apples at the start and we've got 3 apples part way through. So altogether, that's going to make 13 apples. Then I can see that we've got B's, so let's call those bananas again. So I can see that we've got 2 bananas and we've got 5 bananas. So altogether, we have got 7 bananas. And again, yes, we could add those together and say we've got 20 fruit, but again, we've lost information. We don't know how many apples and how many bananas. We're going to leave it as it is. Now, moving on to question 5, you might spot something there that makes it a little bit more complicated. We'll start off with our method. So we've got A, we've got 3a, and we've got a 2a, and then in the other colour, we've got a 3b, and we've got a B. Now we can see here we've got adds and we've got takeaways in here, and this is going to get you a little bit confused about exactly which numbers you're adding up and which numbers you're taking away. For example, you might be tempted to write down 6a because you got a 1a, 3a, and 2a, but one of them's got a minus sign near it, and that's going to change things for us. So you'll notice I've highlighted the letters and numbers, but what about the add and take away symbols? Well, the add and take away symbols always belong with the term after it. The first add sign belongs with the 3a, the second add sign belongs with the 3b, the takeaway sign belongs with the 2a, and the second takeaway sign belongs with the b. So when you highlighted, also include the plus and minus symbols as well, and include them with the term after, so you don't get confused. So now we can read through this and try and get an answer. So I'll look at the A's first. And it starts off with A. Now there's no number on A. I want you to think about a little kind of quirk of language here. If I say that I have got 1 apple, then that could be represented in algebra as 1a. And if I say I've got 2 apples, then this could be represented in algebra as a 2a. So pretty basic so far. Now what if I say I've got an apple? I haven't actually used a number here at all, but it still represents having 1 apple, even though I didn't say the number 1. So you don't actually have to say the number 1 to say you've got an apple. You can just say a. And so with 1 apple as well, it's the same thing. That 1a and a are the same thing. It's just shorter to not bother writing down the 1. So coming back to question 5, when we just have an a at the start, that means I've got 1 apple. And we're adding on 3 apples, which is 4 apples, and then we're taking away 2 apples, and 4 apples take away 2 apples would leave us with 2 apples left. And hopefully you can see that by highlighting that negative sign, it's made it easier to kind of visualize what you're actually taking away. We can do the same thing with the bananas. So we've got plus 3b, 3 bananas, and then it says take away b. And again, there's no number on the b, but you could just say I've got a banana. You're not saying the number 1 in that statement, but you're telling yourself that you've got 1 banana. So 3 bananas take away 1 banana would leave us with 2 bananas. Now if you're not sure if that's a plus or minus 2b, it's a positive number. Positive 3 take away 1 is a positive 2. So our final answer is 2 apples plus 2 bananas. One last little note, when we're adding up and taking away, you can think about if you're adding, maybe someone is giving you things, maybe you've bought them, and if you're taking away, maybe you've eaten them, maybe you gave them away to somebody else. Moving on to the medium questions, another thing that might come up in collecting like terms are multiplications as well. Now, this is a little bit different, so let's look at the first question. We've got 3a times 7a. Now, we've used a method for the easy questions, let's say 3 apples multiplied by 7 apples. That statement doesn't make any sense practically, so we're not going to use that example. Please just use that example for adding and taking away until you're confident. So what do we do here? Well, we're going to separate this up into a number section and a letter section. So looking at question 1, we've got the number 3 and we've got the number 7, and then we've got the letter A and another letter A. And we'll deal with these separately. So let's look at the numbers in green first. That would read 3 times 7, and we can do 3 times 7. 3 times 7 is 21. Now let's have a look at the letter section. Now we've got A times A. And again, like I said, apple times apple doesn't make any sense. And you can't actually do A times A because A as a letter is representing a missing number, a number that we don't know. So we can't actually do the multiplication. So what do? Well, we don't do anything. We just leave the A's. So I've got 21 and then I've got an A times an A. And in algebra, we don't write the multiply signs usually. So rather than writing A times A, I've just written AA. Now that might look a little bit odd to you, and there is a way we can simplify this. We've got 2 A's. So rather than writing the letter A out twice, what we can do is, alternatively, we can write a power 2 to show that we had 2 A's being multiplied together. So the big thing here is you can sort out the numbers, you can multiply those. If it's a divide, you could divide them, but you can't do anything with multiplying and dividing letters, so you have to leave them as they are. So looking at question 2, following the same method, we have a number section, we have a 6, and we have a 5. And then we have a letter section, we have a B, and we have a B. So we'll do the numbers first. 6 times 5 is 30. Then we can do the letters. We've got B and a B. So we're going to write down that we've got 2 B's. And we're not adding them, we're not writing a plus sign in there. They're being multiplied together. So we write them next to each other to show its multiplication. And again, because I've got 2B, rather than write the letter twice, a better way would be just to write a power sign. 2 B's, write a little 2 as a power above the B to show we're doing B times B. Question 3 follows the same method. So we have got an 8 and we have got a 4 for our number section, and 8 times 4 would give us 32. Then we're going to look at our letter section, and we've got an A and we've got a B. We can't multiply them because we don't know what A and B represent, so we're just going to pop A and B on the end. And this time we don't have any repeat letters, so we're not going to write any powers here. We're just going to write an A and a B. Question 4, it's similar, but we've now got an extra term, but we can follow the same method. So number section first, we've got a 5, we've got another 5, and we've got a 2. There's multiplication signs in between, so 5 times 5 is 25, and 25 times 2 is 50. Then we're going to look at the letters, and we've got an A, we've got a B, we've got a C. We know that we can't multiply letters, so we're just going to pop them on the end. Got an A, a B, and a C, and we don't have any repeat letters, so we're going to leave it like that. Now looking at question 5, looks a bit different, but it's the same method. So look at the numbers first. We've got an 8, we've got a 3, so 8 times 3 would give us 24. Then we look at the letters, and we've got a C. Now we've got two numbers together here, but it's going to work the same way. We've got an A and a B. So what we can do now is just add the numbers on the end, so the letters even. So C and A and A B. Now there's one last detail here. Now this is a perfect answer. 24 CAB is 100% correct, so you'll get full marks for it. But what you might see on exam mark schemes, maybe mark schemes your teacher might give you, is they might write it like this instead: 24 A, B, C. Now this is exactly the same answer. All they've done is put the letters in alphabetical order, and you'll usually see them in alphabetical order. So don't worry if you've got your letters mixed up. It's still correct, it's still full marks. So this is just so you know when you see answers and you're a little bit unsure. The reason this works is, if you think about multiplication, it doesn't matter which way around you do multiplication. So for example, 8 times 3 is 24, but also 3 times 8 is 24. So it doesn't matter in a different order. Moving on to the hard questions. Now things look a lot more complicated here, but we've been very patient and follow the steps we've learned. You should be okay. So starting with the first hard question, we've got a 12D. So why don't we call D dogs? So we've got 12 dogs. Then let's look for any more dogs. We've got a 5 dogs. Remember the symbols belong with the term after it. And that's it for dogs. Now we can see we've got a D here at the end, and it's mixed together with a B. So we'll just leave that for now. Now let's look at the next term. Now we've got a B here. So we've got negative 3/2 B, say bananas. We've got a plus 3B, and then we've got another B in the end, but it's mixed together with the D. So again, we'll leave that for now. So we'll follow our method. We'll look at the dogs first. We've got 12 dogs plus 5 dogs, and that will give us 17 dogs. Then looking at the bananas, we've got negative 3/2 bananas, and then we've got plus 3 bananas. Now, another thing you can do here is you can swap them around. It might make a little bit more sense to you. So, for example, saying 3 bananas, take away 3/2 of banana, might make a little bit more sense. Another thing we can do to help here is think about what 3/2 actually means. Now, 2/2 would make up a full banana. So 2/2 would make up 1 banana, and then we've got 1 more half left over. So 3/2 is the same as saying 1.5, and that might help you to kind of visualize what's happening a little bit better. So let's look at this again. We've got 3 bananas, and we're taking away 1.5 bananas. So 3 take away 1 is 2, and then 2 take away a half would be 1.5. So we've got 17 dogs, and we've got 1.5 bananas. Now we have the extra bit on the end, we have the 2BD. So how do we handle that, and what does it represent? Well, for 2BD, I suppose you could imagine that you've got some odd creature that's bananas and dogs mixed together. And it's not dog, so we can't add it onto the dogs. And it's not a banana, so we can't add it onto the bananas. It's something in between. So we keep it separate, and we'll add that on the end. So 2BD. Now it's important to point out these examples, they don't make a lot of sense, just a little bit of fun to help you remember. So when you start getting combination of letters, it doesn't make as much sense practically, and it's not as useful to kind of imagine real life situations to do your maths. So the aim of this is that you use kind of apples and bananas and dogs when you're not very confident, you just learn this for the first time. And then when you start to get more confident with it, then you'll start to not really need those examples. Moving on to question 2, let's look at the A's first. We could say that we've got 7 apples. At the end, we're adding on another apple, which will give us 8 apples. But then in between, we've got the 4a squared, and we've got the 2a cubed. Now, we can add these on to our total of apples. Now, a good way to think about this using a practical example is that with a squared, then you could imagine, say, a box full of apples, and you don't know exactly how many apples are inside that box. So you can't add it onto 8 apples because you're guessing how many are in there. We've got 4 boxes full of apples, who knows what's in them. With a cubed, you could imagine a huge shipping container full of apples that's full of boxes full of apples. And again, you've got no idea how many apples are in there. You know you've got 2 sets of these shipping containers full of apples, but you can't add it onto 8 apples because you don't know for sure how many are in there. So what you would do is you would say that you've got your 8 apples, you know you've got those for certain, But then with the 4a squared, we can't see how many apples are in that a squared, so we're going to leave it separate. And then with the 2a cubed, we'll leave that separate as well because we don't know how many apples are inside that either. And so what you've got to do is, when you've got squared signs and cube signs, you have to treat them as a different object. So we've got a for apples, a squared for a box full of apples, and then a cubed for a shipping container full of apples. Let's look at the b's. So we've got a negative 3b. Again, very important to remember to include the symbol with the term after it. We've got negative 11b, and then we've got a negative 6b. Now, all of these are negative, so again, as a real life example, you can imagine that maybe you used to have a lot of bananas and someone has taken them off you, and then perhaps you owe them some. Maybe you said you sell them 50 bananas, and you didn't have enough to give them, and you said, well, I'll take the money now and I'll give you the rest later. So you owe them some bananas. So let's go through it step by step. So we have negative 3b. We're taking away 11 more. So if you owe somebody 3 bananas and you owe them another 11, you owe them 14 bananas altogether. And then we've got the third term, we're going to owe them another 6 bananas. So if you owe 14, then you owe another 6, you'll be owing them 20 bananas. So you'd write negative 20b. Now, there's one last detail here, and again, it comes down to how you might see these answers written on exam papers. And what you tend to find is answers will put the largest power first. So it will be in alphabetical order, it'll be in order of powers. So this is the same answer. You won't be getting a wrong answer if you write down 8a first, but you might see it written 2a cubed plus 4 plus 8a. So in order of the powers, and this alphabetical order, so the b will be on takeaway 20b. Moving on to question 3, now we have a combination of what we've seen in the easy and medium questions. So we've got some adds, some takeaways, and some divides. So what do we do first? Well, you have to make sure you're using BIDMAS order. So we're not doing 15 take 4 to start. We've got to use BIDMAS and do the multiplications first. And have a look at the BIDMAS videos if you're not too sure about order of operations. So we do the multiplication first, and what's on the multiplication? We've got the 4b and we've got the negative 4b. Again, very important here to remember the plus and minus symbols with the term after it. So we do need to include the takeaway, and this will be the place where most students will make a mistake. So let's do the multiplication first. So 4 times 4 is 16. And then we've got a b times a b. So we'll write our 2b's. So just follow the same rules we use for the medium questions, but of course we've got 2b's, so rather than writing b out twice, what we can do is use a power instead, because we've got 2b's. And then we've got to look at the negative number as well. We've got a negative number multiplied by a positive number, which will give us a negative number. And you can see we're mixing quite a few topics together here, so again, if you're not sure about BIDMAS, have a look at BIDMAS questions. And if you're not sure about positive and negative numbers, then that'll be something you'll see in the BIDMAS topic as well. Once we've dealt with multiplication, now we're going to deal with the adding and subtracting. Now, what we can see here is we've got a 15b and we have got a plus 4b. And we just use the normal rules for this. We've got 15 plus 4, which is 19. So 15 bananas plus 4 bananas is 90 bananas. And again, you want to keep this separate. Again, b squared might represent a 16 boxes that are full of bananas. You don't know exactly how many are in there, so you can't add it to the 19 bananas you've got loose. You've got to keep them separate. And before we move on, there's one extra detail, and again, it's about how you might see these answers written down on exam papers. So negative 16b squared plus 19b is absolutely correct, and you'll get full marks for it, but you might see it written the other way around. 19b take away 16b squared. Look at how many symbols I've used to write this down. With the first alternative, if you just count up all the symbols, we're starting with a negative. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 symbols. If you look at what I've just written underneath in blue, we've got 1, 2, 3, 4, 5, 6, 7, 8 symbols. So we've used one less symbol to represent it. And the one that we're not using is the plus sign. And that's because if you have a number without a plus sign, you just assume it's a plus. So if it's at the start of an expression, then it's going to be assumed it's a plus. So the 19b in my alternative version doesn't have the plus on there. You assume it's plus because it doesn't have a symbol at the start of the expression. So again, there are exceptions to writing it in power order, and this will be one of them if you can write it in a way that has got less symbols. Moving on to question 4, again we've got a mix of adds and multiplications. We have to use BIDMAS rules, and we do the multiplications first. So we've got the 6b is being multiplied by the 5d. So let's do that. Again, we'll have a separate number and letter section, like medium questions. 6 times 5 is 30. Then we've got a B and a D. We don't have any repeat letters, so let's look at the adding. So we've got a 3B at the start, but at the end we've got a 3DB. And like I was saying before, we have to treat these as separate objects. Again, the practical example, we've got 3 bananas, and then we've got 3 banana dogs, which are something in your imagination. You know, we can't add them together, so we have to keep them separate. So we've got the plus 3b and we've got the plus 3db. Now, actually, we're not finished here, because if we look at our final answer, we've got 30bd and 3db. Now, these are actually the same term, and it all comes down to multiplication. It doesn't matter which order you do it in. So again, for example, 6 times 5 is 30, but 5 times 6 is 30. And I also said before, you normally see the letters written in alphabetical order. So rather than writing DB, we could swap the order and put them in alphabetical order and write BD. And this is one of the reasons why we do write them in alphabetical order, because it's easier to see if you have an identical term. And we can add the 30 banana dogs to the 3 banana dogs, and that would give us 33 banana dogs and 3 normal bananas. So we can combine the first and last term because they have the same letters involved, even though the order was the other way around. It's important to point out here that with question 2 and question 3, when I showed the alternative answers, they didn't actually give you any additional marks. It's another way of writing the answer. But with question 4, the 33bd plus 3b, that is actually the way the answer has to be written. And if you did write it using 3 terms, with a 30bd plus 3b plus 3bd, that would actually not get the marks. It's not been simplified fully. That's an important distinction to make. Now with question 5, we're bringing another topic in. We're bringing in quadratic equations and double brackets. So again, before you do this question, you might want to have a look at the videos on those topics just to make sure you're fully confident. But what we want to do first is, since we've got a squared bracket, we want to get rid of that first before we start doing any collecting of like terms. So if you've got 3c plus 4 in a bracket and it's got a power 2, that means you've got 2 sets of that bracket. And we're going to get rid of the brackets and multiply this out. So we're going to multiply all the numbers by all the other numbers. So we're going to do 3c times 3c. So 3 times 3 is 9, and c times c give us 2 c's, or c squared. Then we would have 3c times 4, so 3 times 4 is 12, and we've got a c on there as well. Then we would do 4 times 3c, so same as what we just did. 4 times 3 is 12, and we have a c in there as well. And then the final part of this would be 4 times 4, which would give us 60. And as well as having the 4 terms from multiplying out the brackets, we have also got the take away c squared that was outside the brackets, and we have got the plus 2c. So it's important not to forget about those. Now you can see that I've colour coded these, and I've colour coded them in terms of which terms are going to combine together. So for example, I've got the 9c squared and the take away c squared. That would give us altogether 8c squared. Then looking at the normal c terms, we've got 12c plus 12c plus 2c. So 12c plus 12c is 24c, and 24c plus 2c would give us 26c. Then at the end, we've got the plus 16. Now again, plus 16 what? So if we're saying that these c's are, say, carrots, I've just done 12 carrots plus 12 carrots plus 2 carrots is 26 carrots. Oh, we're adding 16. Tell us 16, is it carrots? It doesn't have a c on. So we just leave plus 16 on the end. We've not really been told what the 16 is. Maybe it's something else, maybe it's money. Only be added together if they've got exactly the same combination of letters and powers. So we can combine the c squareds, we can combine the c's, we can combine any normal numbers, but what we can't do is combine c squares and c's, and we can't combine c's and normal numbers. So our final answer is 8c squared plus 26c plus 6c.
Ouch! This is why in some videos I have explained scratches.